Hey everyone, welcome to JetQuiz Factz. This is our second video. So no one commented in the comment box, so I selected the topic myself. And today's topic is physics. There will be 5 questions and 5 seconds per question, same as every day. Our first question for today is the SI unit of temperature is option number 1 Fahrenheit, option number 2 Celsius, option number 3 Kelvin, option number 4 Rankine. So your 5 seconds starts now. So let's see what is answer of this question. The answer of this question is option number 3 Kelvin. There's no explanation for this question. The reason I thought I don't think we would need to explain or understand Kelvin. Our next question for today is when light travels from air to water, what happens to it? So it is not asking what happened to it. It is asking what differences do we see in option number 1 speed, option number 2 frequency, option number 3 wavelength, option number 4 all of the above. Your 5 seconds starts now. So we will see what is answer of this question. Let's see. The answer of this question is option number 4 all of the above. So when the light goes through the air and then travels into water, all of the things are changed in light. When light travels from air, less dense, so air is less dense, to water, more dense, water is more dense, it undergoes several changes. Speed, light slows down significantly in water compared to air. So we know that water is more denser than air. When the light goes in air, the light can easily pass through the air, and then when it enters the water it becomes slow because the particles of water make it slow to light particles move. Frequency, however, the frequency number of wave peaks per second remains constant as its intrinsic property of light source. Wavelength, consequently, as the speed decreases and frequency stays the same, wavelength, distance between peaks decreases in water. Therefore, all the three properties experience changes when light enters water. This question tells basic understanding of light wave behavior and how it interacts with different mediums. So our third question for today is a ball is thrown upwards and reaches its maximum height. Which of the following statements are true about the ball's motion at this point? So this is a situation based question. So option number 1, the ball has velocity and zero acceleration. Option number 2, the ball has zero velocity but non-zero acceleration due to gravity. Option number 4, the ball has non-zero velocity but zero acceleration. Option number 4, the ball has non-zero velocity and non-zero acceleration due to gravity. Your 5 seconds starts now. So we will see what is answer of this question. The answer of this question is option number 2. The ball has zero velocity but non-zero acceleration due to gravity. There is an explanation for this question. At the highest point of its trajectory, the ball's upward velocity becomes momentarily zero as it stops momentarily before starting to fall back. However, gravity still acts on it, pulling it downwards, resulting in non-zero downward acceleration. 9.8 meters per second square. On Earth, options 1, 3 and 4 contain partially correct or incorrect information about the ball state at this point. This question accesses basic understanding of projectile motion and the relationship between velocity and acceleration at specific points in time. So our fourth question is, a light ray travels from air, refractive index 1.00, into a transparent liquid, refractive index 1.50. When the light enters the liquid, what happens to it? Option number 1, speed. Option number 2, frequency. Option number 3, wavelength. Option number 4, all of the above. Your 5 seconds starts now. So we will see what is answer of this question. The answer of this question is option number 1, speed. Here is an explanation. Think of light waves like ripples in water. Entering denser water liquid makes them slow down, similar to ripples becoming slower in shallow water. The number of ripples per second frequency stays the same, but the distance between ripples wavelength gets shorter to keep up. Remember, speed is affected by medium, while frequency and wavelength are determined by light source itself. So our last question for today is, which is smallest ever discovered particle? Option number 1, proton. Option number 2, mesons. Option number 3, electrons. Option number 4, quarks. So your 5 seconds starts now. So we will see what is answer of this question. The answer of this question is option number 4, quarks. It is the right answer. Whoever thought it is right, they are all right. Here is an explanation about quarks. Quarks are mind-blowing small. Imagine an apple shrunk down so small it would fit inside a million other apples. That's kinda how they are. They're the building blocks of protons and neutrons, but you can't actually see or grab them because they're stuck together super strong. But even though we can't see them, they're responsible from everything from the color of your shirt to the sunshine beaming down on you. Pretty cool, right? So here is an image of quarks, and quarks are of various types. So like and subscribe our channel, and thanks for watching.